Hello, Math 30-1, and welcome back to your fourth lesson with exponential and logarithmic functions. Today we're going to focus on logarithmic functions. To start off, we're just going to look at an exponential function and see where we might get a problem. Now, let's try and find algebraically the inverse of that. So first is we have to switch my x and y. So I end up getting x is equal to 2 to the y, because inverse means we swap x and y's. Now, I'm running into a little bit of a problem, aren't I? Now look at this. How do I isolate that y by itself? I can't. It's an exponent. If I try to divide this by y, and I have 1 here, divide that by y, I still have a y on that side. So I cannot do that. There is my problem. I cannot find the inverse of this. I cannot isolate y once I get the inverse. So that's why we need logarithms. So let's just start off over here, and I'm going to go over what a log is. All right? Now, a logarithm is the inverse of an exponential function. So, if I want y is equal to log 2x, that's the same thing as x is equal to 2 to the y. Alright? So this is the inverse of this equation there. Because now this is also equal to, these two here are inverses of each other. Or sorry, these two here are equal to each other. And this is the inverse of that. Okay? Right? These are equal, and these are inverses. So this is the inverse of that, and if these are equal, therefore this is also the inverse of that. We'll go through some just to see if we understand. Okay, we'll do quite a few here. Now, let's take a look at this. Which of these label y is equal to log 2x beside the appropriate graph? Well, this here is my, it's like the Walking Dead question. This is my original. We know this is the inverse of this, right? It is the same as that. It is the inverse. Because our problem, the reason why we got logs, is because we couldn't isolate that y. So this is going to be the inverse of that. So this is my, there we go. Now, let's take a look at this. Function, y is equal to 2 to the power of x. What is the domain of that? Well, we learned this from last class. My domain is x is an element of all real numbers. What is my range? Well, my range, remember, we couldn't get 0. Y must be greater than 0. My x-intercept? Well, there is no x-intercept. Y-intercept is 1. My asymptote is at where y is equal to 0 on that line, or the x-axis. Because remember, if I put in negative 500 to there, that's 1 over 2 to the power of negative 500, or 1 over 2 to the power of 500, which still gives me a small number close to 0, but never quite hit 0. Let's take a look at this next one. Y is equal to log 2x. So now we're doing log. It's the inverses. If we remember what inverses is, all my x's switches with y's. So all my x's become y's, and all my y's become x's. So my domain becomes my range, and my range becomes my domain. So let's solve this. I end up here. We want my domain. Well, it's going to be my range. X must be greater than 0. And look at that. Right here it goes forever down, and it should never hit, and it goes forever that way. So x goes forever this way, but it goes also forever down. So x must be greater than 0. It's kind of like that one. What is my range? Well, my range will go forever down and forever up. So my range is y is an element of all real numbers. Well, what is my x-intercept? 1. Y-intercept? Well, it goes down forever, so there is none. And my asymptote is that x is equal to 0, which is the y-axis. Okay? All right. Now, let's take a look at this. Question example number 2. Okay? Here we have the graph of y is equal to 2x. Here we have the inverse of it. Y is equal to that, right? Because this is the same thing, this is the same thing as saying x is equal to 2 to the y. So they are inverses of each other. Now, the first, if I look at this, is it true? Well, here x is negative 3, y is 1 over 8. Here, x is 1 over 8. That's what the y was. Y is 3. We just swap them. So they're inverses. Makes sense. So, it says, what statement can be made from this point here, given that graph? Well, here's my x value. Here's my y value. So I know 1 over 4 is equal to 2 to the negative 2. Is that true? Yes, it is. Let's look at my next one. It says, what statement can be made from this one given this graph? Okay, well, y is 4, and we have is equal to log, and it's base 2, and x is 16. Well, isn't this the same thing as 2 to the 16, 2 to the 4 is equal to 16? That is true. This is the inverse of that. Okay? That's it. This is like saying that, which is true. These are inverses. Okay, here we go. Now. Oh, sorry. So now, let's continue this here. It says, complete the task below, form the logarithmic function. Okay, so let's complete this here. We get, oh, these aren't inverses of each other. These are equal. These are inverses of that. Okay, so we get 2 to the 4 is equal to 16. All right, so that's how that goes. Okay, now, right here it says the logarithmic function of the example. Okay, so we want to make equivalents to this one. So we have log 2 to the log 2, log base 2, 4. Well, what is that saying? That's saying 2 to the power of something is equal to 4. So we have 2 to the power of x is equal to 4. Well, what is that? X is equal to 2. Now this one here, we're going to reverse it. This is going to give me log, and we're in base 2, that's my base, okay, is equal to 1 over 4, something, -2. All right, let's try to look at the next one here. Okay, so we have, remember, this is my y, that's my x. This is y, that's my x. These are inverses of each other, but if I say that's y, that's x, these aren't. Just making sure that's clear so you understand what's happening. If you have more questions on this, ask me tomorrow. By the end of the lesson, if you still have questions, ask me tomorrow, and I'll clarify it a little bit more for you. So here we want 2 to the power of something is equal to 2. 2 to the power of x is equal to 2. X is going to be equal to 1. This next one here, we want, well, we're in base 2, so that's log 2. And then we have 1 over 2. 2 to the power of something is equal to 1 over 2, and that something is -1. Last one here, we have 2 to the power of x is equal to 1. Well, that's an identity, so we get x is equal to 0. Remember? Now, let's take a look at number 3. It says, use patterns developed in this question above, okay, to write a statement for this in logarithmic form. Okay, so that's going to be log, and what are we in? We're in base 10, and we have 1,000 is equal to 3. That's it. So 10 to the power of 3 is equal to 1,000. That's all we have to do. Then it says use the patterns to develop a logarithm for this one. Okay, a logarithmic sentence for this one in exponential form. So that means 5 to the power of 4 is equal to 625. And that's it. Okay, this is equivalent to that. Now, if I say this is y and this here is x, that's equivalent to this, right? That's the same graph. If I said this is x and this is y, this is the inverse of that graph, okay? Box, this would be inverse. This is, the circles are equivalent. The boxed ones, if I'm using the circles, they're equivalent to that graph. If I'm using the boxed one, it's the inverse of that graph, okay? So, let's continue this here. It says, these are just some basic rules to go over. The x-intercept is always going to be 1. If we notice, we're just looking at this. There's no other variables, just y, b, and x. If we're just that simple, nothing else affecting it, x-intercept is 1. There is no y-intercept, okay? The y-axis is a vertical asymptote. The domain is x must be greater than 0. The range is y must be is an element of all real numbers. Because it's essentially the same thing as a logarithmic graph, except we're switching my x and y. So then my range becomes my domain, and my domain becomes my range. That's it. Okay? So we just keep the same idea. Now, it says, state the inverse of the following functions. Answer in the form y is equal to something. So this first one here. All right, we want to state the inverse. Okay? So first of all, we get 3 to the y is equal to 3 to the y is equal to x. Well, that's not the inverse. This is the equivalent. So what is the inverse? 3 to the x is equal to y. Okay? Now let's take a look at this one here. Well, the inverse, first we're going to go x is equal to 8 to the y. Right? That's a y. Okay? Now, I can't isolate for that y. It's hard, so I'm going to log it. So I get y is equal to log 8, and we have x. That's it. So this is the inverse. Notice that? Okay? There we go. Next one says, convert each of the following logarithms from exponential form. Okay? So we're going to complete these two exponential forms. Let's see. So we have 7 to the power of 4 is equal to x. That's it. This next one here, 5 to the power of y, 5 to the y is equal to 15. This next one is saying t to the power of m is equal to b. Okay, these are all equivalent. These are not inverses of each other. This next one here has 5. Okay, let's take a look here. This next one here, we're saying, this is a little bit more complicated. 4 multiplied by, well, we have 4 there, and I want to get rid of this 4. We want to get the log by itself, so I'm going to divide both sides by 4. So I have 5 over 4 is equal to log b 6. Now that looks better, doesn't it? So I'm going to have b to the power of 5 over 4 is equal to 6. There we go, that looks a lot better. Let's take a look at my next one here. It says, convert each of the following exponents to logarithm form. Okay, so that is log 4 to the power of something is equal to the power of 3 is equal to 64. Okay, this next one here, we're making this equal, so I'm going to have negative 3. So we have negative 3 is equal to, because we're always trying to solve for the exponent. We have log, and we're in base 2, and our answer is 1 over 8. That's maybe a better way of looking at it. Let's take a look at this one here. D is equal to, well, we have log, and we're in base e to the power of f. And the next one here, well, we'll try and find my exponent. 5, what is that equal to? Log, and we're in base a to the 2x plus 4. Put that in brackets. All right? So that's how we do that. Okay, let's take a look at question number 7. It says, calculate t if log x is equal to 3, log 2x is equal to 3, and log 2 base 2 to the t is equal to x. All right, so let's try and find this one. So let's first convert these into exponential form. All right? So this one right here, I could solve for x by converting to exponential form. This is saying 2 to the power of 3 is equal to x. That's nice. So I get 8 is equal to x. So I know x is 8. So now I have log 2t is equal to 8. Once again, the thing I don't know is that. We know my exponent. So 2 to the 8 is equal to t. Alright? So then we end up getting t is equal to 256. And that's everything. So that's my answer. See how I did that? And I'll move this in for there. Alright, so now we're going to look at the logarithm form of y is equal to abx. Okay, so change each of the following exponential form to logarithm form. So we want to change each of these from exponential to logarithm form. Alright, so what I have to do here is, first I'm going to isolate for my variable the best I can. We want to isolate for the variable the best I can. So we have y over 2 is equal to 3 to the x. There we go. Now we have my exponent variable isolated the best I can. Now I'm going to log both sides. So I get x is equal to log base 3 y divided by 2. That's it. Let's take a look at the next one. Here we have h in the 7. So I'm going to divide both sides by 7, divided by 7. So I get h divided by 7 is equal to 4 to the power of k. So I have my exponent as isolated as I can get. Now I know k is equal to log, or in base 4 over 7. Okay? Let's take a look at my next one. Once again, must isolate my exponent the best we can before we log. So I divide both sides by r. So I get t over r is equal to s to the p. Okay? Now we log it. So we know p is equal to, because logging solving for this exponent, is equal to log, or in base s, and we have t divided by r. That's it. Let's take a look at my next one. Alright, once again, we have that problem. We want to get this, the exponent, as isolated as we can before we log it. So I'm going to multiply everything by 2 over 3. So I get 2y over 3 is equal to 10 to the x. Now I can solve for x. X is equal to log base 10 2y over 3. That's a y. Okay? And that's it. Next one says, change each of the following logarithms to exponential form like that. So we have to isolate then for y. Okay? So first, this is saying 7 to the power of x is equal to y over 3. Well, multiply both sides by 3, so I get 3 multiplied by 7 to the x is equal to y. Okay? Here it's saying 10 to the power of x, so 10 to the power of x is equal to y over 4. Multiply both sides by 4, I get 4. 10 to the power of x is equal to y. Okay, that cancels off this, which is multiplied by 4. Now we look at my next one. We have log 5, 7y is equal to x. So we have base 5. So it's 5 to the power of x is equal to 7y. We want y by itself, so we divide everything by 7. I'm going to end up getting 1 over 7, 5 to the x is equal to y. Okay? Now, I didn't put this over 7 because it's only 5 to the x. So we just got to kind of isolate that. Maybe put this in brackets there, put this in brackets, put this in brackets, just to make sure you know that this x only relates to the 7 and not the 3. It relates here to the 10 and not the 1. Okay? Let's take a look at the next one. Alright, so we're saying e to the power of x is equal to y divided by 5. Okay? So multiply both sides by 5. I get 5 multiplied by e to the x is equal to y. And that's it. Alright? So that's everything. Hopefully you understood. Good luck as I see you tomorrow as we start on the assignment. If you're having problems understanding when it's the inverse and when it's not, make sure you ask me tomorrow. I'll be going around to double check it with you. Okay? We'll see you tomorrow and good luck.